I just want to share the screen also to show something here right now. Before we start, before we start. Okay. One thing I just want to show before we start, it's recording right now, that's fine. Here, about the previous example, which we did. When we said we have two conditions here. We said x does not equal -3. So x does not equal -3. That means there is asymptotes when x equals -3. So if I put a vertical line here, it cuts x equals -3. That is, we call it asymptote here, asymptote. Okay. And same thing for y, because we say y does not equal x, does not equal 0. Y does not equal 0, right? So if y does not equal 0, that means when I put here on the x, on the horizontal, the y1, which equal does not equal 0, there is also asymptote here, horizontal asymptote at y equals 0, horizontal asymptote at y equals 0. So I have two asymptotes now, the one of the -3 and the one for the 0. And here we have asymptotes at y equals 0 and asymptote at x equal -3. This is because of what? Because of the conditions of the y does not equal 0 and x does not equal -3. I just want to remind you back, asymptote means that it's not making intersection with the point or not with the, so it goes parallel, very narrow with the horizontal and the vertical axis, but does not intersect with them. We'll go to the next part right now of our own work. And just I will show some points about also the here. I think this is very clear, guys. For each of the following functions, determine f2, f -5, and so it's I did two examples on the board about this. However, I will show you this example how to solve it. As example, fx equal 2x -4, and you just want to put f2, find f2. Just remove the x and put 2 instead. Remove the x and put 2 instead for f2. So here it will be 2 times 2, that's 4, -4, that will equal 0. So the point will be when x equal 2, y will equal 0. The meaning of this, that fx, you can replace it with y. Y can replace the word fx. This is the meaning of it. So we say x, when x equal 2, then y in that case will equal, f2 will equal 0, then y will equal 0. The point will be 2 and 0. That's everything. And I will do it on the board also in 1 minute so that you guys can understand it clearly more than just pointing with the pointer here. So I will do it, and let me just show it on the board. And I think on the board it will be very clear, more obvious for you guys than this. Here we go. Let me just show it here so it will be clearer to everyone. The example is here. Let's go to it right now. I'll do the same example which I did, which I point out to right now, and I'll do just this example again. Boy, working on the board. So the example was here, fx equals 2x -4. Fx equal 2x -4. 2x -4. And he wants the point when x equal 2. When x equal 2, that's the point which he wants. So he needs the value of fx when x equal 2. So I will replace the any x I will see here with 2, with this 2. So I will say then fx will equal 2 times 2 instead of x minus 4. 2 times 2, this is 4 minus 4, that will give me 0. So fx means y. Then y means 0. So I have the point, I have x equal to, this is x, and I have y equal 0. So the point will be 2 and 0, because this is for x and this is for y. 2 for the x and 0 for the y. Likewise, the other two examples which you have here in that example, the other two are the same. So it goes the same like. I'll share the screen back to go to another ideas in our curriculum. And I will just move forward right now into another slide. Here's the slide which I'm working on. These are other examples. All the examples are the same. It shows you here as example when we say f2 means that I will remove x and put 2 instead of it. So 2 power 2 minus 2 and so on. So here minus 2 plus 7, that will be f2 will equal 17. So the point will be 2 because I assume that x will equal 2 and the y or fx equals 17. So the point will be 2 and 17 on 7. Same likewise, the other ideas, all the ideas are the same, and you can just work on it also for this. Here, another figure to show you the domain and the range. The domain we said is x, the range is y. And if you notice, while we are working, about the domain and the range, if you notice one thing, that maybe more than value for x can give the same value for y. But the opposites never happen. More than one value for y can give the same value for x? No. So as example, if I say as example, let me just show something. And with this example, guys, you will understand what I mean here. Let me say I will go back to the board, again, back to the board, and I will go for a just very little example or simple example. If I say like this, if I say like this, fx will equal x squared. So this is y. This is, we consider it y will equal x squared, because fx, we can replace it with the word y. Suppose now when x equal minus 1, then fx will equal minus 1 all square, that will give me 1. Okay, so when x equal 1, I'm just assuming, once I assume that if x equal minus 1, and now I'm saying x will equal 1. So then fx will equal 1 square, that will give me 1. I have the same 1 in the two cases. In both the cases, we have the result is 1. So y has only one value, which is 1, but x may be with different values. So the range might be many numbers, but only one number for the y will get. So this, in that case, it's a function. If fx give me the same number, that's a function. That happens sometimes. While we are working, I will show you the examples. Remember this figure, please. Many figures for x, for the ranges, give, for the domains, give the same range of y. Okay, guys? So that I just want you to remember this figure before I move into another idea right now. And here we go for the idea which we are talking just about it right now, the domain and the range. So this is as example here. This is domain. And this is the range. So here 1 is going to 5 for the range y, and 3 is going for the range, the same range. But here 2 from the domain go to 1 and 2. So the first one is a function, but the second is not. Yes, the first one is a function, but the second one is not. We'll go also right now into C. We have some examples here. We'll have some examples here. Here, if we say about the how to find the domain and the range also for this, same idea. Please look at the board here. We have here now, but this is not the vertex here. It's going because the A is minus. I just want you to see this now, please, and pay attention to what I will say here in this point. Here, A, because we say A x squared plus bx plus c. We put the form of any equilibrium like this. So I have the form before in the previous page. It is minus 3 t plus 1 all square plus 5. So this is the, let's say t plus 1 is x. So minus 3x squared, which means in another way that the coefficient of the highest power, A, is minus 3, which is less than 0. As long as A is less than 0, then I'm expecting that the curve will take this figure. And it will be a max. The vertex will be max. So as long as A less than 0, the vertex will be max. Look at this. The vertex at what? Minus 1 and minus 5. Why? Minus 1 and minus 5. I will tell you. Because this is the point where the curve make a turn. This is the point when the curve make a turn. So this is, we call it the vertex. And here, this we call it maximum, not minimum. This is a maximum point. Okay, that's why, because the A is here, the coefficient. A is the coefficient, which is minus 3. This A is minus 3. Okay, so as long as A is minus 3, which is less than 0, that means that the curve will be like this figure. It will be opened to the down to the minuses, and in the same time, the vertex will be this point, minus 1 and 5. Minus 1 and 5. Same likewise, what I did here in this figure, vertex usually is the coefficient of the n and the absolute margin outside. This is the vertex. So if I want to get the vertex without solving, I can get it from here. This will be minus 1, and I will take the 5. This is the point which should for the curve. But if I want to do it, I will just replace this way, same way, minus 3, minus 2, minus 1, 0, 1. And I will graph the other point here, the t or the y. Then I will go for getting the vertex, which is the point of the turn, will be the vertex. If I want to find h minus 7, then I will substitute in the formula. I have the formula minus 3, here it is, minus 3 t plus 1 whole square plus 5, and I will do it here like this, minus 3 minus 7 plus 1 whole square plus 5. That would then minus 7 will equal minus 103. Okay. Also, we can see that this starting from, as long as it's like this way, it goes from Q3 into Q4, because it's a quadratic as well. Okay. This point, we had it before, we mentioned it, so there's no problems now. Like we said here before, once in the equation A is positive, then I'm expecting that the curve vertex will be down here. I'm expecting that the curve vertex will be down. Same thing, this is a quadratic function, and A here is positive, so the curve will be down like this. And these are the vertex of the curve, minus B divided by 2A, and minus B divided by 2A as well here in this point. We'll go right now into study one more thing about the trinomials and so on. Okay, guys.